Hello, algebra. We are going to look at composite functions or composition of functions today. The video notes are going to be in this blue text box here. And the first question is to find m of 4. Remember, we read that as m of 4, which means 4 is the input into the m function. So I look at the m function here in red, and I know that m of 4 can be calculated by substituting in 4 for x. So I'm going to pop that 4 in there. 4 plus 5 over 2. And as I evaluate that, that becomes 9 over 2. So my final answer could be written as just 9 halves, or m of 4 equals 9 over 2. Either of these would be acceptable answers. So that's just your kind of standard warm-up problem for an input to output. Now, if you look at B, part B here, you'll notice there's an extra set of parentheses, an extra function in here. So if I had to read out the directions of this one, it would be to find k of m of 3, which is kind of complicated, k of m of 3. And one important thing to note when we are looking at composite functions or composition of functions is that we want to work from the inside out, meaning we want to begin in the middle or the furthest inside that we can. So I'm going to start with this chunk here, this m of 3. All right, so that means that 3 is going to go into the m function as an input. Now I'm going to do this with arrow notation here. So I'm going to show 3 is going to go into the m function, and I'm going to ultimately get something out of there. All right, we'll calculate that in a minute. Then that something is now going to go into the k function because m of 3 is actually the input into the k function. So the output of the m of 3, so 3 goes into m, whatever comes out is actually going to be my input into the k function. So I'm going to then substitute whatever comes out of the m function into the k function to get my final answer. I'm actually going to put that in swirls instead of a box there. So let's see what that looks like. First, I'm going to find m of 3. And you can show your work however you want here. I'm going to just substitute 3 into the m function, which becomes 3 plus 5 over 2. 3 plus 5 is 8 over 2 is 4. So 4 is the output when 3 goes into the m function. So I'm going to put 4 in my little box here. So 4 is the output. Now I need to find k of 4. So the output of the m of 3 becomes the input into my k function. So now 4 goes into k, and I need to calculate k of 4. So k of 4 means 4 is the input into my k function, which is 2x plus 1. So that's 2 times 4 plus 1, or 8 plus 1, or 9. So 9 is my ultimate answer, like the final answer of this, because 9 is what comes out when 3 goes into m, and that output goes into k. All right, and I know that's a lot of talking, a lot of writing, so we're going to do one more example to see if you can follow around here. So in letter C, my goal is to find m of k of 11. So m of k of 11. And again, that means I want to work inside out. So the first thing I'm going to do is find k of 11. So I'm going to start with my input of 11, and I'm going to pop it into the k function. So k of 11. Now I'll show my work of that down here. That would be 2 times 11 plus 1, 22 plus 1, or 23. So now that output is 23. Now 23 is going to go into my m function as its input. So I'm going to have 23 plus 5 over 2. So I'll write that here. Now I'm finding m of 23. 23 plus 5 is 28. Divided by 2 is 14. So my final output here is 14 as my ultimate answer. And that's because when 11 goes into k, I get an output of 23. Now that output becomes the input into the m function, so m of 23, which gives me 14. It'll be the same idea with the rest of this extension. You'll have to do some of the same types of problems in A, B, C, and D of number 2, and then the same idea with tables and with graphs, right? So good luck on this extension. There will be some hints for you along the way, and feel free to reach out to your teacher if you have any questions.